Images in curved mirrors. Okay, so yesterday we saw the rules in our last lesson about how we draw reflected lines. To very quickly review them, if the incident ray is parallel, if the incident ray of light is parallel to the principal axis, then it comes in and it bounces through the focus, right? If the incident ray is on a line through the focus, like this, then it would reflect parallel. If a line is coming through the center of curvature, it reflects back on itself in the same sort of way that it came. And then we said that if something actually comes in and hits the vertex, it reflects like it would off of a straight mirror, a plane mirror, like this. And these angles are basically the same. That rule we don't use very often because it's hard to gauge about the angles, right? So what we're doing here is we're doing sketches. So we're not concerned with getting precisely the exact degrees or angles. We're just kind of drawing some sketches to figure things out. Okay, so we're going to use those rules now to look at a mirror. We'll start with a converging mirror, something like this, shiny on the inside, and we'll label the focus right about here and the center of curvature, which is about the same distance away, like that. That actually is a little bit off, so let me fix it. The better you do this part, the better the whole thing works. Okay, so what I'm saying is this distance right here should be as close as possible to that distance right there for a circular mirror of this type. Okay, now what we need is we need an object to reflect in the mirror. We could put a dog or a watermelon or a kidney, it doesn't matter, but we're going to use, in green here, a simple arrow. And what we're going to see is that depending on where you put it, you get all different possibilities. So our first example is going to be putting our object way out here. So we'll draw a little arrow like this, and I'll draw this arrow a little thicker so he doesn't look like one of our light rays. Remember, we use an arrow because it has a definite top and bottom that's easy to see. So this is the object that we're going to look at in the mirror. So we can put object here. Okay? Okay, so we want to find out where is the reflection? Where is the image of the object? And what's cool with curved mirrors is that sometimes the image is not even in the mirror. It's actually outside of the mirror, and it's in the real world. They can actually project an image onto a screen of some sort, and you can actually see it. So let's take a red line here, and let's do our first. Let's pick any two rules. That's the beauty of it. All you need is two lines to cross to find a point. So we're going to imagine, don't draw this part. We're going to imagine that light is going to hit the top of this, but we're not going to draw that arrow because it's confusing. We're just going to look at the light after it bounces off of the tip of that arrow. We're going to imagine that it's going to bounce off in many different directions, right? But one of those directions will be straight like this, parallel to the principal axis, and it will go here and strike the mirror. So there's one incident ray of light that could come off the top of the arrow. And the rule is, since it's parallel to the principal axis, remember this line down here is the principal axis. It's just a reference line. It's not a real thing. But that means that this will it will actually bounce in a direction that is going through the focus or on a line through the focus. So we can draw, wow, this thing keeps jumping. There we go. We can draw our line as straight as possible. It's best to use a ruler, okay, and draw it like that. I can already see that my line's a little crooked, so I'm going to stand back a bit and draw it more straight. There, that's a little straighter. Okay, so there's the first reflected ray. Doesn't tell us much. But now we can do a second reflected ray, which I'll do in blue. And this one, we're going to use a different rule. We're going to use an incident ray of light that's on a line through the focus. So this time, we're imagining another ray of light that shoots down like this and goes through the focus and strikes the mirror this way. So there's my second incident ray. There's actually hundreds of these rays that are all striking the mirror at different places. But because of what we studied and because we know how they reflect, these particular ones are quite useful. Now when I draw my line, this has to reflect parallel to the principal axis. Something like that. If you've done it right and you're careful, the place where they meet will be in between the focus and the center of curvature, if your picture is done well. And that's important because that's where it should be. What that means is that's where the tip of the arrow of the image would be found. We could do more. We could go to the vertex, and I'll show you this, but don't draw it because it's confusing. But even if we did another rule, if we went to the vertex like this, you can see that it would bounce back at the same angle right there, and that line would also go through that spot. So every possible light ray that comes off the tip of that arrow is going to go through this spot. So that's where all the light rays converge. That's where we would find an image of the tip of the arrow. So let me erase those purple lines so they're not confusing our picture. Now, what's interesting is if we do the same thing from the bottom of the arrow, we end up with that weird situation. Remember we said that anything that's on the principal axis, all of the rules result in the same scenario. So what that means is that if you shine light rays from the bottom here, again, you don't have to draw this, towards the mirror, every rule means that it will bounce straight back along this line. That means that the bottom of the arrow has to be located on the principal axis. It has to be, because there's no other place where lines could cross if they were coming from the bottom. So what that means is our arrow image is going to have a bottom on the principal axis and a top at the meeting point of these two lines, which means it's going to end up being upside down. And our arrow will be located right here. Okay? Now there's a couple of things we can notice about this. And when we're sketching, sometimes our picture doesn't quite work out. But once you sort of know what to expect, then you can actually determine. What we want to do is describe this image that we've made. So this green one is the image, right? And in fact, maybe I'll color it in purple so that we look at it as a different thing. It's the image in the mirror of the arrow. So I'll write over here, image, right? So now what we can do is we can describe the characteristics of this image. We're going to talk about its properties. One of the things we like to look at is the size of the image. The size, right? Now, sometimes we use another word for the size, and that is the magnification. The magnification of the image. If you look at the green arrow and then the purple arrow, you might notice from the picture that the green arrow is a little wee bit longer. It's a little wee bit longer, which means that the image is a little bit smaller than the object. Okay? If you haven't drawn it very carefully, you might not notice that. But the image here is actually a little smaller. All right? You'll notice that if I just use yellow, the distance between here and here is a little bit bigger than the distance between here and here. So the purple arrow is a little bit smaller. So what we're going to do is we're going to use that. So there's two options. Basically, the image can be smaller. Actually, there's three options. It can be bigger, or it could be the same, right? The same size. Those are the only options you can have. And we are going to say that this one is a little bit smaller. So in this case, using those three words, we would write smaller. The image is smaller. Now, the other thing we like to keep track of is the orientation of the image. Is it upside down or upside right? And you can see here, it's pretty obvious it's upside down. So the second characteristic of an image that we like to keep track of is the orientation. Whoops, let me get this, the orientation of the image. Get this back to black. Orientation. And of course, it's either going to be upright or inverted. Those are the two options that we have here. And if you look at ours, you can see that it is inverted. It is upside down, right? The arrow's pointing upside down. So we say it's inverted. Okay? Good. Now, the other characteristic that we like to sort of look at is its position. Where is it? Where is the image found? And so its position now, there are several options. What we do is we divide up the places where things can be depending on the focus and the center of curvature. So again, don't draw these things into your picture because it's confusing, but the image could be in here, and we would call that between V. Remember, this is the vertex V right here. That's between V and F. Or sometimes we just say inside of F, inside F. So that's one spot, inside F. The other place the image could be is between the F and the C, like ours right now. So that's another spot. Well, there's actually a couple different ones, but okay, inside F, between F and C. And the other spot is anywhere out here, which would be beyond C, outside of C. So we often will say beyond C. And of course, there's a couple other options too. The image could occur at right on F or right on the C. The image could show up right on those spots. So there's basically 5 different places where the image could be. In this case, we see that it's between F and C. So that what we would choose is this one. This is the characteristic of our image, between F and C. And now there's another characteristic. It's sort of the last characteristic that we like to discuss, and it's called the type of image. And there's 2 choices for this. It can be a real image, or it can be what's called a virtual image. Now, a virtual image is an image that appears inside the mirror. The only way to see it is to look into the mirror. And of course, a virtual image isn't really there, is it? When you look at yourself in the mirror, there's not another you standing behind the glass. If you go in behind the mirror to look for that image, it's not there. You can't touch it. You can't grab it. You can't do anything with it. Okay? In fact, all you can do is look at it through the mirror. A real image, however, is one that exists out in the real world. And the trick to knowing whether it's a real image or not is that you can actually hold a little screen, a piece of paper or something. You can hold it there and collect or capture the picture. You can actually do that, and I'll show you that with a demonstration a little bit later. You can actually capture the picture. Now, in this one, if you think about it, Mirrorland is all over here. This is sort of the inside of the mirror place. But our image is not in the mirror. We're not looking into the mirror. our image is actually outside in the real world, which is on this side. The real world means the same side as the object, right? That's another way to look at it. If the image is on the same side as the object, they must both be in the real world. If it's way over on the other side, then it's the opposite of that. It's in the virtual world. So in this case, what we have is a real image. It's out here on the same side. Another way to think of it is if the image is formed using reflected rays that cross, it will be real. But if it's formed by imagining where the rays came from, remember in the last lesson we talked about especially with diverging mirrors, you have to imagine where the rays come from back inside the mirror, and we use dotted lines to show that. If it's dotted lines that are crossing, it tells you that it must be a virtual image. So the two options are real and virtual, and for us, we pick real for this image. Okay, so the next time we're going to do about 4 different examples now. We're not going to write all of these things out. We're just going to write whichever one it happens to be, okay, just as a shortcut. So you'll notice that here, we can title this, our object beyond C. That's where the object was. See here, it's out past C, our object. And these are the characteristics that go with what happens when you draw an object out beyond C. So now we're going to keep moving our object closer to the mirror and see what happens. We're now going to take our object and put it right on top of C in our next picture. And we're going to draw the rules and see what happens. So we draw another mirror. And after a while, this gets pretty straightforward because we start to understand how this works. Remember, try to make these two dots almost exactly the same spacing. That's if you don't, you won't get the proper images. And we're going to draw, so that's the focus right here, and this is the C, the center of curvature. We're going to put our arrow right here, right on C. So we can call this object at C and see what happens. Okay? We're going to do the same thing. We're going to draw our two rules. We're going to take a line that is parallel to the principal axis. Actually, you know what? I'm going to go thinner just because it's a little bit... Okay, make it very careful. I know it's only a sketch, but if you draw your line like this, whoop, and it's clearly not parallel because you were not paying attention and you were lazy, it's not going to work. You have to draw this as parallel as you can with the principal axis. And the rule is it will reflect through the focus. Draw this line as straight as you can. A ruler helps. A ruler would help. Okay, now let's do the second rule, which is a line through the focus. So we reflect, reflect down this way. And we go down. And if you've done this right, when it reflects across, see, I'm not quite right there. This thing should be right underneath. So let me just fix it, because this is the demo, right? We want to make sure that this works. Let me try to... pretty close. Again, I'm off. Let me try one more time with a smaller line. It's tricky to get it right when you're not using rulers and measuring. So like that. Whoops, now I missed the focus. So what I'll do is I'll just fix that by making the focus a little bigger. Okay. And then what should happen is it should sort of cross right about there. So, but that line should be parallel. You can't do this. You can't bring it over here and then draw it down. You have to make it look like it's parallel, because that's the rule. A line through the focus is parallel. And what we would find is our image then would be formed right here at C. There's our image. And here's our object. Okay? The other thing I've noticed is you see my mirror is a little off. You see this vertex? It really should be about here, shouldn't it? So that's creating a bit of a problem too. These sketches don't always work out as nicely as you would hoped. So you know what? What I could do is I could change that. Let me see what happens if I go back here. I guess I'd have to go all the way back to the start, right? Let me just erase this and try to make this mirror a little more realistic. Because see, that changes where it hits down below. And that changes everything. So there, let's fix that. And now let's see if I can get rid of my blue line there. No, it's not going to let me. I have to erase. Get my red line back. And of course, it's a little fussy because we want to make sure that the video looks the way it's supposed to look. Now that's looking a little bit better. And then when I do my blue line, it's going to come through here. It's going to hit a little sooner. And then when it comes across over here, well, now see, now it's off again. It's very difficult. I think my mirror still looks funny. Maybe that's part of the problem. Let's try this one more time. My mirror still does not look, I think I may have erased the mirror when I was doing the, whoops, people are jumping around. Okay, let's try this one more time. Let's make the mirror sort of look like the V is in the center of the curve, which means that this line is going to strike now a little bit sooner. Right, a little bit sooner. So something like that. And then it should come over here. It's still a bit off, unfortunately. But the idea is that this is where things should end up. So I'm not sure why I can't get that to work out. Sometimes it just is annoying. I'll try one more time here to see if I can't fix why this is happening. Now it's erasing. I'm trying to do too many things with this smartboard, which is right now not as smart as I would like it to be. There's my mirror again, so we have that. Then we have our blue line. It's got to sort of cross over here. You know what I think the problem may be? I think it may be my red line. Never even thought about that one. See how it's bending away here? It wasn't very straight. Not having a ruler on this smartboard makes it difficult to do. So let's try the red line again and see if I can't make that improved. Whoops, now I kind of went the other way. That's even worse. Maybe that'll work. Blue. Oh, that's about as close as we're going to get. I think that works pretty good. So it was the red line after all that trouble. So there's the tip, and there's the object. And this is looking pretty good now, because what was concerning me before was the fact that the object and the image were two different sizes. Here's the object, and here's the image. And now that we've got everything sort of straightened around, we can see they're about the same size. That's what's important. Okay, so let's do the characteristics of this image. In fact, maybe we can just sketch them over here beside. The characteristics will be the size, or the magnification. I wish it would remember the line. Size, well, it's the same size in this case, or at least it should be. Okay. The orientation is inverted. Inverted. The location, or the position, I think we used the word position before, right? So the position or location of the image is right on C, or right at C, and the type of the image is, again, a real image. Real, just like the other one, because it's on the same side. Real image. Okay, let's draw another one. This time we'll move our object between F and C. And this time I'll be more careful about drawing my mirror so that we don't get this. Okay, so we'll draw here a line. And it's really this curve that is the problem. I think that's a little better. The vertex should look like it's right in the center of the curve, right? And then we can put our F right here, and then I'll try to get that exact same distance here with C, and we'll put our object somewhere in between this time. Maybe I'll make that a little smaller, because I kind of know what's going to happen. So let's go a little smaller. There's our object, okay? And you can write object beside there if you want to, just to remind you that's the actual thing that we're looking at in the mirror. Let's draw some lines. So the first one would be parallel, and then reflecting in a straight line like that through F. That looks pretty good. The second rule would be going through F, and then reflecting out like this parallel. Again, that one's a little bit, maybe it's because I went too thick. I got to try to draw straight lines. That's better. Okay. Actually, I don't like that one either. Try it one more time. No, still, I'm going up on that second part, and I don't want to do that. There, that's about right. Now it's looking good. Okay, so the image, the tip of the arrow will be over here. And the arrow will be way up here like this. And it should look bigger this time. And it should be out past where the C is. So here the characteristics of the image are, and again, we can look at the different things. So we have the size or the magnification. Now it's bigger, right? That's the size. Bigger. The orientation is still inverted, upside down. And the position is now between. Nope, sorry, it's outside, not between. Outside of C. Outside C. And the last thing, of course, is the type, and it's still a real image. Okay. Next thing is to put it right on the F and see what happens. Okay, we'll try to draw that example. So let's go at F. We didn't write here what this was. So we titled the first one object at C. So this would be object between F and C, right? That was what that one was. That's where the object, it's pretty obvious. You can see that. Okay, let's draw another one here. Principal axis. Try to get a good mirror. That one looks not too bad, I guess. We'll get an F over here, and we'll try to get exactly the same distance for the C, F and C, and we're going to put our object right on the F. And let's see what happens. Now here's what's interesting. The first ray is going to come across like this, and it's going to go down through the focus like this. That's the first rule. Parallel reflects on a line through the focus. But the second rule is not much good to us, because a line through the focus would be going sort of straight down through the object. And of course, the light can't go down like this through the object. So we can't get a light ray to go through the focus from this position. So that rule won't even help us. So we could try the other rule. Maybe we could use the center of curvature rule. We could say, what happens if you're on a line through the center? Well, now remember, you're not going to go this way, because that would never hit the mirror. All of these rules, the reason we say on a line through is we imagine a line like this, going through the center towards the mirror. That's the line we imagine through the center. The light ray would be on that line, but it would be going towards the mirror from the top. So it would just be this part. There's the light ray on a line through the center, see? And of course, the rule is it would bounce back on itself. So this actually would reflect right back along this line and go this way. And you'll notice it's parallel to the other red line. At least it should be. Mine's was pretty close. So they'll never touch or meet. So that doesn't help us. We need a meeting point. We need the lines to cross. So the only rule left, I'll do 3 on this one, just is the purple. We'll do the rule of going to the vertex. So we go down to the vertex, and we look at this angle, and we try to reflect on the same angle, like that. And look, it's parallel again. None of these lines are crossing or touching. So that means that if there's no crossing or touching, there won't be an image. At least not on this side of the mirror. Whenever lines don't cross or touch on one side, we can imagine where they came from and see if they might appear to cross inside the mirror. But if we extend these lines back, since they're parallel, we know that it will not matter. They won't meet inside the mirror, and they won't meet outside the mirror. And so when this happens, we get the interesting situation of no image forming. So we can't actually get an image if you place the object at F. So that's kind of an interesting situation. Our last situation is if we put the object inside of F. So let's do one more picture to show our very last scenario of the object inside of F. So we'll draw our line like this. Now I'm going to move my mirror here. I'm going to move the mirror a little bit more to the middle, and you'll see why. Okay, and I'll put my F here, and my C right there. And I'm going to put my little object right in here, and I'm going to draw the object very small, so we have room. Okay? Maybe a little bigger than that, just a touch bigger. So we can actually see him. He looks a little bit. There's my object. Let's do the lines. If I go parallel to the axis, I must go through the focus. Boom, like that. Now, on a line through the focus, that's the second rule. The light is going through the focus. I can't go this way because I won't hit the mirror. That doesn't make sense. So what I have to do is I have to imagine the line through the focus. There's the line through the focus. So my light ray is going to start at the top and go towards the mirror this way. It's going to go like that towards the mirror, which means it will bounce parallel and it will go out like this. And those lines don't cross. Okay, so we don't really need this dotted blue line. I'm only drawing that to show you what to imagine, right? So that's not really necessary. But our lines don't cross, so there's no image. But this time we have to look at what happens inside the mirror. So now we're going to extend those lines backwards. Remember, when we extend them backwards, what we're actually doing is we're imagining an eyeball that sees this ray of light. And the eye and the brain don't realize that it's bounced off of a mirror. They think that the light has come along in a straight line. So it looks like it came from somewhere over here behind the mirror. And we can extend the red line the same way, imagining what an eye might see. And when you do that, they do cross. They cross in the mirror world, which means that's where the tip of our image would be. And just like before, the bottom of the image is always on the axis because all of the rules produce that result when you go from the bottom of the arrow, and there's what we get. So this time we have a very strange difference. This is my image over here in purple. Whoops, image. And in green, this is my object. Things have changed in terms of the characteristics. The first thing we notice is the What are we doing first? It doesn't really matter the order, but I'll keep the order. We were doing size first. So, okay, so size is bigger now. This is the first time we've seen, I don't want to use green because that looks like the object, and these are the characteristics of the image. So if anything, I should use purple, right? These are the characteristics of the image. So its size is larger or bigger. That's the first time we've seen an image that was larger. The position, no, I think it was orientation next. Again, it doesn't matter. The order's not relevant as long as you get them all in there. So orientation. This time, we see that it's upright. It's not inverted anymore. That's the first time we've seen an image that was the right way up. Then we have the position. For this one, we can't really say that it's anywhere. It's not inside F. It's not between F and C. The position here, we just put inside mirror. It's inside the mirror. Okay, that's another option that we can get here because it's on the other side. And then the type, well, here's the interesting thing. You can't go to this place inside the mirror. That purple arrow exists in mirror land. There's no way to get to it. So it's what we call a virtual image. And again, you can see it's virtual because it's formed by the crossing of the dotted lines where we imagine the light to come from. More like an illusion, right, that the brain sees. Okay, so these are the ways that you can get an image in a converging mirror. There are many examples, and you have to learn what the characteristics are that go with each of these positions. Now, you can memorize them, or you can learn to draw the sketches. You should probably be able to do both, because if I gave you a test, I would ask you to draw a sketch like this, exactly like this. I would say, draw a sketch that shows the image in a converging mirror if the object is inside F. And you would have to start and do this and draw all this and show that you know the rules and draw the lines and get the image. And then you would have to list these characteristics of the image. So memorizing them helps when you're drawing so you know what to expect. But you can't just rely on memorizing them if you don't know how to draw the image. So you have to practice both. Okay, now, what about a diverging mirror? That's the other one. Turns out it's a lot easier or simpler. And that's because there's really only one option. So let's look at what happens if we use a diverging mirror instead of a converging mirror. So we'll draw our axis this way. This time we're going to flip the mirror around like that. See, that doesn't look very good. I can see already that my curve is a bit off, so that's a little bit better. Now the focus will be here. And then we want the same distance away for the center of curvature, so about there. And this is shiny on the outside. So there's really only one place you can put the object, somewhere over here. You can't put it anywhere else. That's basically the only option that you have. You can't place it in mirror land. And if we follow our rules, what we'll see, here's parallel to the principal axis. Okay, now you got to be careful. It has to reflect on a line through the focus. Well, it's not going to go like this inside the mirror. You can't penetrate the glass and go inside. So that's wrong. What you have to do, again, is envision a line through the focus from that spot. And it has to reflect along that line, which means it would have to reflect out this way. So there's the first rule. The second rule is a line through the focus. Well, again, you can't just draw a line like this and go inside the mirror, because when you hit the glass, you have to bounce. So what you have to do is you have to envision first the line from the tip going through the focus. There's the imaginary sort of line through the focus. And the light ray is going to follow that line towards the focus, but it's going to stop at the mirror, and it's going to bounce back parallel. That's the rule. So the lines, it's the same rule, but they just look different each time. Now you'll notice that the lines do not meet on the right-hand side, but they do meet inside. Now, unfortunately, again, I'm a little bit off on my picture, so let me just sort of fix it so it looks appropriate. We want that to actually be, yeah, so I'm gonna try to draw this line in blue a little bit. No, that didn't work either. Hang on. Oh, actually, you know what? I'm okay. Never mind. I'm a little bit confused. So we're okay. There was nothing wrong with the picture. There, that's what we had. Okay, now, those dotted lines, we really shouldn't draw them. We should just imagine them. I'm drawing them on the board here to show you what to imagine, but drawing those lines confuses the picture. You just kind of line up your ruler on the focus to make the line, and line up your ruler on this one to make the line. Don't actually draw those lines, because they're not the kind of lines we want. What we want to see on this side of the mirror are the lines that show where these light rays seem to have come from. So if an eyeball were to see this blue ray of light, it would think it came from somewhere back here. Dotted line. And if another eyeball were to see this red line, it would think that it came from somewhere in here. Okay? And in fact, that one, I should have that. It should be going right through the focus, except I went off a little bit. Let me just, like that. There's the reflected ray. So those are the lines that we want to draw, because those are where it looks like the reflected rays come from. And you'll see that what we get is an arrowhead right here. And then draw the arrow down to the axis. Remember, the bottom of the arrow is always on the axis. So here's what we get. There's our image. Okay? Remember, the dotted lines have to be drawn backwards from the reflected rays, not the incident rays. After you reflect the rays, you draw those lines backwards. Okay, that's important. Then what do we got? Well, we have the characteristics of this image. So, first of all, the size. Smaller. The orientation. This one is upright, not inverted. The position is inside the mirror. And this time the type is also, remember, where is it? Is it in mirror land, or is it in the real world? Well, the real world is on this side of the mirror. Mirror land is on the other side. This is a virtual image, because it was not formed by the crossing of any real light rays. It was formed by imagining where the light rays came from. So it's a virtual image. And really, this is the only option for diverging mirrors. This is the only picture we need to draw, because no matter where we put that arrow, that green object, it's going to result in a similar kind of picture. But this one's tricky to draw, because you have to do a lot of extending of the lines. Okay? You have to be able to extend the lines. And you have to know which lines to extend. And so that is how we find images in diverging and converging mirrors. All right, we're going to take a break and we'll practice this a little bit. And then we'll look at applying mathematics to this and actually develop some mathematical formulas that will allow us to predict where these images are and their types and magnifications and so on.